Music is a fundamental aspect of society that is sometimes overlooked or taken for granted. It is a long-standing cultural tradition that can have immense significance and meaning. Music is a combination of sounds which vary in pitch, timbre, rhythm, beat, and volume. It is variations in these basic components that make music so unique. This presentation will explain how sound is produced and manipulated in relation to the physics phenomena to form differing musical styles and diverse final products. All sound can be simplified into one word: vibrations. Sound waves, unlike electromagnetic waves, must have a medium to travel through, meaning they cannot be produced in a vacuum such as space. Most commonly, sound waves travel through the air around us until the vibrations reach the ear, where the mechanical vibrations are interpreted by the cerebrum after being converted into electrical signals by the ears. These mechanical waves can be explained by using the slinky analogy, where the periods of compression and rarefaction are where the slinky is stretched out and where it is compressed. The amplitude of a frequency is the volume of the sound. In terms of sound waves rather than human perception, the amplitude is characterized by the maximum displacement that is achievable through the given medium from its point of equilibrium. The wavelength refers to the pitch of the generated sound. In practical terms, it refers to the length of one full wave cycle. The wavelength value can be found by measuring the distance between consecutive troughs or peaks. The shorter the wavelength, the higher the frequency, and therefore the pitch. In this investigation, a song was chosen that exemplified the psychedelic rock genre. This genre is characterized by electronic instrumentation and layered vocals. The song Eventually, by Tame Impala, was analyzed using software called Audacity. When examining the chorus compared to the verses, a definite rise in amplitude was recorded. This is typical of most music genres, where the volume and density of sound generally increases in this part of the song. Beat is a concept that is extremely familiar in the musical world. When analyzing the song in Audacity, consistent periods of increased amplitude are indicative of this. There are overlapping frequencies throughout all music which cause interference. Interference is caused when two frequencies are played together to create either constructive or destructive frequency. A constructive frequency causes the amplitude to be greater, and a destructive frequency achieves the inverse. This song exemplifies a type of interference called beat frequency. This occurs when frequencies that are slightly differing in pitch are played at the same time to cause repeated variations in amplitude which are known as oscillations. This is an example of both constructive and destructive interference. This occurs due to the slight difference in wavelength causing peaks and troughs to fall in and out of sync in a constant pattern. In relation to the song Eventually, an electronically produced sound from a keyboard exemplifies this throughout the track, where the dissonance and amplitude fluctuations can be heard easily. Every object has a resonance, which is the lowest frequency that it is capable of producing. Resonance can be demonstrated by observing a wine glass when its edge is circled with a finger. Its lowest resonant tone is produced. When air is passed over a closed-ended air column, such as a pan flute, the resonant tone is also created. Continuing with the pan flute example, the pitch of an instrument is proportionate to its length. Shorter lengths produce higher frequencies because their resonant tones are higher. Therefore, pipes with shorter lengths need a higher wind speed for their resonant tone to be produced. In the investigation, closed-ended air columns were made using lengths of PVC piping. Random pipe lengths were cut and their frequencies were recorded in Audacity. A power relationship was observed between pipe length and pitch. An equation was generated to predict the pipe length for the scale of E major. Pipes were cut and observations were recorded. The model that was constructed was relatively accurate, with all of the cut lengths coming within 10 Hz of the target note. The timbre of sound, known as the sound quality, is affected by three main factors, these being the harmonics of the tone, attack decay, and vibrato. Harmonics are tones which are produced by the resonator at whole number multiples of the fundamental frequency. In the case of a closed-ended air column, such as a PVC pipe with a stopper attached, this instrument will only produce harmonics that are odd multiples of the fundamental frequency. The timbre of an instrument can be manipulated by the musician by changing variables such as embouchure and wind speed. The plot spectrum in Audacity provided data for the harmonics of the produced sounds. It was obvious that the sound produced was not a pure tone. This could also be observed from the time frequency plot, where the wave pattern was not in a perfect sine wave, but rather had an erratic quality. This is a result of the timbre of the instrument. I attempted to reproduce the tone of the constructed instrument in Audacity by using the fundamental frequency and the following harmonics of the tone. This was successful to a certain extent. I was able to create a tone that had similar qualities in relation to pitch and amplitude. However, the sound quality of the tone was vastly different. This was mainly due to the instrument being played using breath. This in itself will change the properties of the sounds being created. The tone that was produced using pure tones in Audacity sounded like this. The tone that was created using the instrument sounded like this. As you can hear, the difference in sound qualities are quite distinctive. This was due to the variables such as method of sound production and the materials used to make the instrument. All of these variables contribute to the differences in the timbre of the sound. This presentation has outlined how the physics phenomena of frequency, amplitude, and interference relate to the musical phenomena of pitch, intensity, and timbre. Hopefully, after this presentation, you have an increased understanding of the concepts surrounding these topics and a greater appreciation for the complexity of music. Thank you for listening.